Hello students. So in this video, we're going to start with a new chapter, that is real numbers. Okay. A very, very important chapter. So real numbers. Basically, what are real numbers? Okay. Now, so far, you have learned different types of numbers, isn't it? So let's recall those things. You have learned something called as natural numbers, isn't it? Natural numbers, which is denoted by capital letter N, isn't it? Which is denoted by capital letter N. What are these natural numbers? The numbers which start from 1. This is the definition that usually you guys say, isn't it? But it is not correct. It is 50% correct, not completely correct. Because when you say the numbers which start from 1, and if I ask you 3.5, does it belong to natural numbers? You may think, okay, the numbers which start from 1, 3.5 comes after 1, then it should belong to natural numbers. So this is the mistake that you guys do. Okay, 3.5 is not a natural number. So what are natural numbers then? How to define it properly? Those numbers which are used for counting. That is the important word. Okay, numbers used for counting purpose. Okay, those type of numbers are called as natural numbers. Okay, how do you count? Say suppose I give you some chocolates and ask you to count how many are there. How do you start? You start with 1, 2, 3, 4 and so on, isn't it? That is why we say the numbers which start from 1, but the correct way is the numbers which are used for counting purpose. Okay, so in this end we have got 1, 2, 3 and it keeps going. Okay, those are natural numbers. Okay, to this natural numbers, if I just include one more number, that is 0, then it is known as a new type of number known as whole number. 0, 1, 2, 3, so on. Okay, without 0 it is natural, with 0 it is whole number. Okay, let me write that also, whole number. Okay, then we have got something called as integers. What are these integers? This is a group. Okay, integer is a group. What do we have in this group? We have 0 in this group and all the positive numbers, 1, 2, 3, so on, and the negative numbers, -1, -2, -3. To be precise, the correct way is 0, positive natural numbers and negative natural numbers. This is the exact definition. Okay, positive natural numbers, negative natural numbers, and 0. Negative of natural numbers. That's what I mean by negative natural number. These are natural numbers. If I put minus, it becomes negative of natural number. Okay, so how do you denote integers? It is denoted by capital letter Z. Okay, now in all these things, we know what belongs in that group. Say suppose if I take natural numbers, what is there in this group? 1, 2, 3. What should not be there in this group, or what doesn't belong to this group? 0 doesn't belong to this group. Do we have any negative numbers? No. Do we have any fractions or decimals? No. So in natural numbers, we won't have 0, we won't have negative numbers, we won't have decimals or fractions. Coming to whole numbers, do we have 0? Yes, we have 0 here. But what? We don't have fractions or decimals, and we don't have negative numbers. Coming to integers, we have negative, positive, 0, everything is there. Then what is not there? Decimals are not there, or fractions. Suppose if I give you -3/5, it is a negative number. -3/5 is not an integer. Okay, it is called something else. Okay, -4.5. It is a negative number, but it doesn't come in integers group. Integers group have got only a natural numbers and negative of natural numbers, which means they don't have fractions or decimals. Okay, the next type of numbers is known as rational number. Okay, what is this rational number? Those numbers which can be written in the form of P by Q. Whenever you are able to write a number in this form, where P and Q are integers and Q should not be equal to 0. q should not be equal to 0. Okay, why q should not be equal to 0? Let's understand with some examples. Okay, let's take some positive rational numbers. These positive rational numbers are actually called as fractions. What is the difference between fraction and a rational number? Both are almost same. Okay, fractions are only positive, but rational numbers can be positive and negative. Okay, so let's take some rational numbers like this. In fact, these are also called as fractions. 3 by 5, 2 by 7, okay, 0 by 3, 3 by 0. Okay, let's take this. This is not a rational number, isn't it? Because the denominator should not be 0. Let's understand why it should not be 0. Okay, now 1 by 4, this is the fraction, right? Basically, fraction is used to represent a part of something. There is something big, one full apple, you write it as 1. But if I take a small piece out of it, how do I represent it mathematically? You represent it using fractions. Okay, say suppose you take half apple. How do you represent it in maths? We write it as 1 by 2. 1 by 2 is read as half, isn't it? So these fractions are used to represent a small part of something big. Okay, now let's take this fraction 1 by 4. Basically, this denominator tells you the complete thing, the apple or chocolate, whatever it is, the whole thing is divided into how many equal parts. The denominator tells you how many equal parts the whole thing is divided into, and the numerator tells how much we have taken. Okay, for example, let's take a cake like this. Okay, now the denominator is telling you the cake is divided into 4 pieces. Okay, so 1 by 4, I'm taking only one piece out of it. Is it correct? 1 by 4, this is 1 by 4. Okay. 3 by 5. Let's say there is a cake again. Let's divide into 5 equal parts. 1, 2, 3, 4, and 5. Okay. Imagine these 5 parts are equal. Okay. Now, I'm taking 3 parts out of it. This is 1 part, 2, 3. Possible? There is a cake. I'm divided into 7 pieces. For 5 pieces, out of this 5 pieces, I'm taking how much? 3. The denominator tells you how many pieces you have divided the apple or cake or whatever. The numerator tells how much you have taken. 2 by 7. Again, the cake is divided into how many pieces? 7 pieces. I'm taking 2 pieces. Okay. Now, coming to this 0 by 3. Okay. Let's understand this 0 by 3. Is it possible? Yes, it is possible. If numerator is 0, it is possible. Why? The apple or the cake is divided into 3 pieces. How many pieces I'm taking? 0 piece. It makes sense. Okay, there are 3 pieces, but I am not taking anything. Okay. Now, what about this 3 by 0? There is a cake which is divided into how many pieces? 0 pieces. The cake is divided into 0 pieces, but I am taking how many pieces out of it? 3 pieces. Does it make sense? The cake or the apple is divided into 0 piece. We have not at all divided it. But how many pieces I'm taking? I'm taking 3 pieces out of it. Does it make sense? No. That is why you should not have 0 in the denominator. If you have 0 in the denominator, we say it is not defined. You cannot define this. Okay. That is why in rational numbers or in anything, the denominator cannot be 0. Okay. Now we have learned this: natural, whole numbers, integers, rational. The other type of number is known as irrational number. What is this irrational numbers? The opposite of rational. Rational are denoted by Q. Irrationals are denoted by Q dash. Okay. So what are irrational? The numbers which you cannot write it in this form. If you can write in this form, then it is rational. If you cannot write it in this form, then it is known as irrational. Okay. So let's understand that. Okay. The numbers which cannot be written in the form of P by Q. Okay, that is Q dash, irrational numbers. Okay, irrational numbers which cannot be written in the form of P by Q is known as irrational. In other words, non-terminating and non-recurring. If there is, for example, non-terminating means the decimal doesn't stop, it keeps going. Non-recurring is there is no repetition, there is no pattern. For example, If you observe this 4.57, 57, 57, 57 goes on. This doesn't stop, it keeps going. So it is non-terminating, but it is recurring. There is a pattern that you can observe. 57, 57, 57, 57. This is recurring. Suppose if I take like this 1.108922875603215 something. Here you can see there is no pattern. There is no pattern repeated. There is no pattern repeated. Therefore, we call this as non-recurring. At the same time, it is not stopping, so it is non-terminating. Such kind of things, these kind of things you cannot express in terms of P by Q. You cannot write this in terms of P by Q. Therefore, these are called as irrational numbers. Okay. There is also one more thing. If you are not able to find a square root or cube root of any numbers, then those square root of that number and cube root of that number are irrational. To be simple, to make it simple, root 2. Can I find square root of 2? Can we find? What do you mean by square root of 2? A number which multiplied by itself should give you 2. Please do not tell it as 2 ones are. 2 ones are is not correct. 2 is a different number, 1 is a different number. You take any number multiplied by itself. That is why we write square root of 25 as 5, because 5 multiplied by itself. 5 5s are 25. Square root of 16 is 4, because 4 4s are 16. Square root of 9 is 3, because 3 into 3 is 9. Any number multiplied by itself should give you the answer. But square root of 2, there is no number as such which multiplied by itself will give you root 2. No, there is no number as such. Therefore, these kind of things, root 2, can you find square root of 3? Cube root of 4? Square root of 4 is possible, but cube root of 4 is not possible. What do you mean by cube root? A number multiplied by itself 3 times. Suppose if I ask you what is cube root of 8, you give me as 2. Why? Because 2 into 2 into 2. 3 times if you multiply, you get 8. Cube root of 27 is 3, because 3 multiplied by itself 3 times. 3 into 3 into 3, you get 27, isn't it? So if you're not able to find square root of a number, cube root of a number, all those things come under irrational numbers. Okay, two different. These are the things that you have learned. Okay, now coming to real numbers, all these numbers together is known as real numbers. He is the boss. He is the CEO of the company. Okay, under this person, we have got so many things. Okay, to make it simple, real numbers can be divided into 2 categories. Okay, real numbers can be divided into 2 categories. Let me tell you that. What are those 2 categories? Okay, once again, let me erase this completely. Okay, real numbers is divided into 2 categories. One is rational and irrational, which we are going to see in this chapter. We are going to solve certain problems on irrational and certain problems on rational. Okay, now real numbers is basically 2 different categories. If I can represent it like this. Let's take a big circle. Okay, this circle is representing real numbers. Okay, in this circle there are 2 persons. One is rational, another one is irrational. I'll write it inside itself, irrational. Okay, inside this rational we have got integers. I'll write Z here. Okay, I'll write Z here, integers. Okay, okay, meaning, okay, he's the big boss who has got 2 persons under him, rational and irrational. Okay, irrational doesn't have any person inside him. Okay, no one is working below him. This rational has got integers. Next level, the next lowest level is whole numbers. Okay, and the next lowest number is natural numbers. Okay, remember this. So rational below rational, we have got 3 more persons. Integers, below integers, we have got whole numbers. Below whole numbers, we have got natural numbers. This is a better way of remembering. Okay. I can also tell you this. Observe, the natural number is inside the whole number, isn't it? The natural number is inside the whole number, which means every natural number is a whole number. Every natural number is a whole number, but the other way is not true. Every whole number is not a natural number. Okay, because 0 is a whole number, but that doesn't come in natural number. This you can remember it very easily. Okay, let me write that separately here. Okay, first comes Q. Inside Q, you will have Z. Inside Z, you will have W. Inside W, you will have N. Okay, so every natural number is a whole number. Similarly, every whole number is a integer. Possible, but the other way, because this complete whole number is inside integers. W is inside Z. W is inside Z, which means every whole number is integers. But the other way, integer is not inside whole number. Therefore, I cannot say every integer is a whole number. For example, -2, it is an integer, but it is not a whole number. Similarly, every integer is a rational number. You take any integer, it will be a rational, but the reverse is not true. Okay, you can remember such things. Basically, real numbers, as soon as we speak about real numbers, two things should come into your mind. It has got two persons in them. One is real, one is rational, another one is irrational. Rational you can express in the form of P by Q. Irrational you cannot express in the form of P by Q. Okay, this is the basic thing. These are the things that we are going to discuss. Okay, what are the other main things that we are going to discuss in this chapter? It is something called as HCF and LCM, highest common factor and lowest common multiple or least common multiple. Okay, let's understand what are these, what does they exactly mean. Okay, so let's start with highest common factor. Okay, let's go word by word. Okay, highest common factor, HCF. Okay, highest common factors. Let's start with this word factor. Okay, what do we mean by factor? We have also seen in our previous academic years, like factorization. What does exactly is this factorization and factors, all those stuff? Very simple. Factor of a number, if I say factor of 6 or factor of 4, it is simply the number of ways that I can express 4. Okay, for example, if I ask you factors of 4, or to be very simple, this definition will be easy. Which two numbers should you multiply so that you get 4? The numbers that you have to multiply in order to get 4. The factors of 4, I can write it as 1 4s are 4 or 4 1s are 4. Multiplication is commutative. You multiply 1 4s are 4 1s are, both will be same. Okay, so here which are the numbers that I multiplied to get 4? 1 and 4. So factors of 4 are 1 4. Is there anything else? Yes, 2 into 2 is also 4. So the other factor is 2. So factors of 4 are 1 4 2. Let's take factors of 6. Factors of 6. If I want to get 6, which are the numbers that I have to multiply? 1 into 6 or 6 into 1, then 2 into 3 or 3 into 2, both are one and the same. The factors are, which are the numbers that I've used here? I've taken 1 6 2 3. So the factors of 6 are 1 2 3 6. These are the factors. In another word, I can also tell you that factors of 6 are nothing but those numbers which will exactly divide 6. Which are those numbers that divide 6? 1 divides 6. 1 will divide all the numbers. 1 divides 6. 6 divides itself. 2 divides 6. 3 divides 6. So if I ask you what are the factors of 8, you can think it in two ways. What is the first way? Which are those numbers if you multiply you get 8? 1 8s are 8. Okay, 1 and 8 are factors. 2 4s are 8. So 2 and 4 are factors. Anything else? 3 4s are 12, but 3 4s are 12, right? So it's not a factor. I need 8. If you multiply, you should get 8. That is one way. Or the other simplest way is those numbers which divide 8 exactly. Exactly in the sense you should get remainder as 0. Okay. Is this number divisible by 1? Yes. Is this number divisible by 2? Yes. By 3? No. You can't divide 8 by 3. If you divide, you won't get remainder 0. By 4? Yes. Again by 8. Okay. So these numbers are known as factors. I mean, factors of 8 are 1, 2, 4, 8. I hope it is clear. Factors are simply those numbers which divide the given number. Okay. Now, let's come to this word, common factor. Let's take here itself. Let's discuss about this 8 and this 4. What are the factors of 8? 1, 2, 4, 8. What are the factors of 4? 1, 4, 2. What are the common things in them? 1 is common, then 4 is common. Therefore, the common factors are 1 and 4. If I discuss between 8 and 6, what are the common factors? 1 and 2. See, you have got 1 and 2, 1 and 2. So common is simply the numbers that are same in both. Okay. Now let's come to this highest common factor. So which are the common factors of 8 and 4? It is 1 and 4, isn't it? Just observe. The factors of 8 are 1, 2, 4, 8, 1, 4, 2. Which are the things common? 1 and 4, 1 and 4. These are the common things. Which is highest in them? 4. Okay. So the HCF is 4. HCF of 4 and 8 is 4. In another word, I can also say it like this. If the question is HCF of 4 and 8, we write it as 4, meaning which is the highest number that divides these two numbers? It is 4. As simple as that. Okay. You need not do all this stuff. You can directly do it. If I ask you, what is the HCF of 6 and 4? The meaning is, okay, well, let's do the actual way. What is the actual way? Find the factors of 6. The factors of 6 are 1, 2, 3, 6. Find the factors of 4. The factors of 4 are 1, 2, 4. Which are the things that are common? 1 and 2. Among that, which is the highest? 2 is the highest. So HCF of 6, 4 is 2. This is the process. But you can also do it very easily. You got 6, 4. Which is the highest number, a big number that divides both? It should divide 6. It should divide 4. 1. Is there any other number other than 1? Yes, it is 2. 2 divides both. You can divide 4 by 2. You can divide 6 by 2. Can I say 3? No, 3 divides 6, but it doesn't divide 4. Okay. So the highest common factor of 6 and 4 is 2. Okay. HCF of 10, 15. Which is the highest number that divides both? Which is the highest number that divides both? It is 5. 5 2s are 10, 5 3s are 15. You can divide it. So HCF of these two is 5. Okay. HCF is basically the answer which divides both the numbers. Highest number that divides both. Okay. Now let's come into LCM. What is meant by LCM? Okay. LCM is least common multiple. LCM is least common multiple. Okay. Suppose let's start with this word multiple. If I ask you multiples of 4 or multiples of 6 or multiples of 5, it is simply the tables of 4 tables, 5 tables, 6 tables. Okay. Start telling me the 4 tables. 4 1s are 4, 4 2s are 8. So the multiples of 4 are 4 1s are 4, 4 2s are 8, 4 3s are 12, 16, 20, 24, goes on. Similarly, if I ask you multiples of 6, 6, 12, 18, 24, 30, 36, goes on. What about 5? 5, 10, 15, 20, 25. When I say multiples, it is simply the tables. That's it. Okay. You can also take the negative numbers. 4 into -1, -4, -8. The negative of this. plus 4, take negative, minus 4, minus 8. These are also multiples. But in this chapter, we are discussing only the positive multiples. Okay, not the negative. Okay, we have restricted ourselves to positives. Okay, 4, 8, 12, so on. These are known as multiples. Common multiple means what? For example, common multiple of 4 and 6. Those numbers which are same in both. 12 comes in both. 24 comes in both. Then 36 comes in both. You can keep going. These are the common multiples. The word is least common multiple. Which is the least among them? These are the common things. Which is the least? The first one. This is the first one, right? That will be your least common multiple. Okay. It is simple. When I say least common multiple, LCM, it is simply you take 4 tables, 6 tables, which is the number that comes in both, which is the first number that comes in both the tables. It is 12. If I ask you what is the LCM of 3 and 5, you do a method, right? 3, 5, 3 ones are, then 5 as it is. That is a method. Okay. Now, what is the meaning of LCM, least common multiple? Very simple. You take 3 tables, 5 tables. Which is the first number that comes in both? 3 ones are 3, 3 twos are 6, 9, 12, 15, so on. Similarly, 5 ones are 5, 5 twos are 10, 5 threes are 15. As soon as you see, 15 is the first number which comes in both the tables first, right? Therefore, LCM of 3 and 5 is 15. LCM of 4 and 6. Just now we finished it, right? We'll take LCM of 6 and 5. LCM of 6 and 5. You just write the 6 tables one side and you write the 5 tables one side. Which is the first number that comes in both? That will be your LCM. As simple as that. But you've got many methods to discuss. Okay. So this is the meaning of LCM, least common multiple. In another word, I can also say like this. LCM of 4, 6 is 12, isn't it? In another word, I can also say it like this. Which is the smallest number? Which is the smallest number that is divisible by both? 12, right? 12 is divisible by 4. It is also divisible by 6. Meaning 4 can divide 12, 6 can divide 12. This is the smallest number. We have got more numbers, bigger numbers also. After 12, I can tell 24. 24 is divisible by this, divisible by this. Okay. As simple as that. Okay. So HCF and LCM, these are the meaning. Highest common factor, least common multiple. Okay. Now, in this chapter, we are going to learn how to find HCF of LCF and LCM of very big numbers. What I have given here are very small numbers. Okay. Suppose here I have given you the LCM of 4 and 6, which is 12. Easy. Instead of that, if I ask you LCM of 1089 and 2892, can I write the tables of this 1089? 1089 ones are 1089, 1089 twos are 2198 or 188 or something. Can I keep doing that like that? And the same thing, write the tables of this, write the tables of this, and find which is the first number that comes in both. It is not possible, right? Okay, if what if I put one more number here? These are very big numbers, right? We are not able to find the LCM very easily. So then we should have some kind of tricks to do it. That is what we are going to learn. Okay. The very first concept is we are going to learn how to find HCF and LCM of very big numbers. Okay. So the first concept is to find HCF, okay, using something called as Euclid's division lemma. Okay. The first concept, Euclid's division lemma. I can simply write it as EDL. Okay. Euclid's division lemma. Let's simply take it as EDL. Okay. What is a lemma? Basically, it is a statement which is proved. It is already a proved statement which is used to prove something else. Okay, as simple as that. Now, what does this Euclid's division lemma tell you? You take any two integers, positive integers. We can also take negative, but we are restricted ourselves to only positive. Okay. Take any two positive numbers, positive integers. Okay. In general, let's say A and B. In general, let's say A and B. Okay. These two integers, you take any two positive, any positive integers. Okay. There exist two more integers. This is the symbol used for there exists. Okay. there exist two more integers q and r in such a way that this a will be equal to b into q plus r. If you choose this a value and b value, you will get q value and r value, which is fixed. For these two selection, this is fixed. Okay, I'll give you example. Okay, where this relation is satisfied. We also call this as division algorithm. Okay, actually that is a different thing. Okay, but as the process is as most similar. Okay, this Euclid's division lemma and division algorithm, which we are going to look into the next part, they're almost similar. Okay, so people also call this as division algorithm itself. Okay, so in simple words, how to remember this? Very simple. Just remember it like this: the dividend is equal to divisor into quotient. Easy way of remembering this, plus remainder. What is Euclid's division lemma? Dividend is equal to divisor into quotient plus remainder, or a is equal to bq plus r. Let me take two values, a and b. Let's say a is 7, b is some 15. Okay, I can get this relation. I can get such a thing. Observe. Okay, I can write, let me take the other way. Okay, a is considered to be, b is less than a. Okay, it can also be equal, but less than a. Let's take it like that. Okay, a is 15, b is 7. I should have told there itself. A, you're selecting two values, a and b. A should be greater than b. Okay, that is how we have selected. Okay, we have selected like this, a and b. Now I can get this relation. I can write 15 as, observe, 7 into 2 plus 1, isn't it? Observe, this is your a value, this is your b value. Similarly, if I take a as some 10 and b as some 3, then this 10 can be written as 3 into 3 plus 1. If I take a as some 17 and b as some let's say 3, then 17 can be written as 3 into 5 plus 2, isn't it? We're getting a relation. This thing is known as Euclid's division lemma. Okay, now if you observe, we use the word unique. For any two integers a and b, there exists unique integers q and r. What do I mean by that? See here, if these two values are fixed, 17 and 3, your a and b is fixed. This is my a and b. So I can write a as 3 into 5 plus 2, 5 and 2. These are the only things that you will get for 17 and 3. These two are fixed. There is no other way that you can write 17 as 3 into something plus something. There is no other way. It should be only 5 and 2. Other than 5 and 2, you cannot have anything else. That is why you use the word unique. Other than this, you cannot have nothing. Okay, there is no possible that you can satisfy this relationship. Okay, if for example, let's take this, a value is 15, b value is 7. Can I write 15 as 7 into something plus something other than this? See, I can write 15 as 7 into 2 plus 1. Agreed. 15 can be written as 7 into 2 plus 1. Agreed. Is there any other way that 15 can be written as 7 into something plus something? Is there any other way? Any other numbers that satisfy? Let's take 3 and 1. 7 3s are 21 plus 1 is 22. Not possible. There is no possibility at all. That is why we use the word unique. Okay. Let's take this itself, 10 and 3. 10 can be written as only like this, 3 into 3 plus 1. If your a value is 10 and b value is 3, then you can write it like this. Is there any other way? Think 3 into something plus something. Other than this 3 and 1, can you put something else here and make it equal? No, not possible. Okay. Remember, I'm talking about integers, q and r. Don't put fractions here. Okay. For example, people might do like this. Sir, I'll put 1 by 3 here and I'll put 9 here. So 3 gets cancelled. 1 plus 9 is 10. 10 equals 10. Sir, we are getting another number. You said only 3 and 1. We have got another number. But what was my thing? Q and R were what? Integers. They are integers. Okay. They're not fractions. So you cannot take like this. Okay. So this is Euclid's division lemma. In simple words, suppose if you divide 15 and 7, how much you get? 7 2s are 14, 1 carry. Therefore, this divisor, dividend 15 can be written as divisor, that is 7 into quotient plus remainder. That's how we got it. Okay, let's take another number. Let's say you are dividing 19 by 3. Okay, now how do I write? Divide it. 3 6 are 18, 1 is the remainder. So how do you write 19 as? Dividend is equal to divisor into quotient 3 into 6 plus remainder. Okay, so the thing that you have to remember in Euclid's division lemma is this stuff. Dividend is equal to divisor into quotient plus remainder. Okay, and one more stuff is this R value, okay, will always be less than this. Okay, will always be less than B. Okay, whatever your B is, it will always be less than that. It cannot be greater or equal also. Okay, you cannot have equal or greater than this. Okay, so we'll discuss more about this when we start doing the problems. Okay, this is just an introduction of real numbers. What are real numbers? What you have got two things in real numbers, rational and irrational. Then what is factor, highest common factor, what is multiple, least common multiple, and I've also given you Euclid's division lemma. Okay, in the next video we will start solving the problems, that is how to find HCF using this Euclid's division lemma. What we learned now is dividend is equal to divisor into quotient plus remainder. This is known as Euclid's division lemma. This is used to find the HCF of two given numbers, very big numbers. You can find it. Once we finish that HCF, then let's learn how to find the LCM of big numbers. Okay, thank you, students.